Today, we are going to talk about something that is called factor, factor pairs. Why factor pairs are important? Oh, because factor pairs are small indicators of how we can play around with the same number to get to it. We can use different numbers, or they're called factors, and we multiply them and we will get to the same result. For example, we can get to number 15 by counting only once by 15. All right? Easy. Only once, only once. We just count once by 15. But we can get to number 15 by counting by, right, by fives, three times. So factors are numbers being multiplied to get to a result. Our result is 15, and we see that we can have here two factor pairs. Once 15 and three times 5. All right. Number 12 is a tricky number. It can get more factor pairs. Always we are checking three factors in order to proceed and not to lose any sight of extra factor that might be of interest. We always check factor number 1, we always check factor number 2, and we always check factor number 3. When we have factor number 2, we have to check factor number 4, and when we have factor number 3, we double check if there is anything related to factor number 6. Right now, we will see that any number can have one factor and will always have one factor itself and number 1. Itself and number 1. Can 12 be divided by 2 equally? Right. It can be divided by 2 equally, or 6 multiplied by 2. If we're counting by 6 twice, we will get to 12. As I already mentioned, we always check factor number 1, factor number 2, and our next step is check factor number 3. We ask ourselves a question: can 12 be divided by 3 equally? Yes, that's right. It can be divided by 3 equally, and it means that 3 times 4 is 12. You remember the trick? 1, 2, 3, 4. 1, 2, 3, 4. Right? Easy way to remember 3 times 4, or 4 times 3 is 12. If we calculate number of pairs, we see here only 3 pairs. But if we reverse 12 times 1, 2 times 6, and 4 times 3, we'll get 3 more pairs over here. So the total number of pairs would be 6. All right, we've got number 28, and we understand that it can be split more than once. We're checking factor number 1, factor number 2. Let's check factor number 3. In order to check if 28 can be divided by 3, we are having a trick in mind. We put an imaginary plus in between and ask ourselves, 2 plus 8 is 10. Is 10 can be divided by 3 equally? No, no. 9 can be divided by 3 equally. 12, yes. But 10, no. That's why 28 cannot be divided equally by 3. And we cannot put 3 here. But we know that if factor 2 is possible, factor 4 is going to be possible as well. Counting by sevens 4 times, 7, 14, 7, 14, 21, 28. Factor 2 became doubled, and we are checking factor 4 just in case for numbers bigger than 12. All right, as we can see here, the number 28 is a composite number. It has multiple factors. All right, and we got a bigger number, even 81. Right, what the trick about 81? What about trick about big numbers? We use an imaginary addition mark here, and we say 8 plus 1 is 9. Perfect. 9 can be divided by 9. And 9 can be divided by 3. Perfect. Factor number 3 is here, and factor number 9 is here. And always we have factor number 1, which is the same number being repeated once. 8 plus 1 is 9, and 9 can be divided by 3, and 9 can be divided by 9. Wow. We have a perfect square here. 9 times 9 is 81. Perfect. And how are we going to divide 81 into 3? I know by steps. 30 plus 30 and plus 21. 30 divided by 3 is 10. 30 divided by 3 is 10. And 21 divided by 3 is 7. Right. And we are having is 10. 10 and 7 is 27. Perfect. All right. Oh, this number is easy and hard at the same time because it's a composite number. And we see that it's a even number at the end. So it can be divided by 2. And if it can be divided by 2 and it's bigger than 12, it can be for sure divided by 4. And let's check if it can be divided by 3. 2 plus 4 is 6. 6 can be divided by 3. Perfect. And 6 can be divided by 6. Right. So 24 can be divided by, right, can be divided by 3 and can be divided by 6. It can be divided by 2 and can be divided by 4 and can be divided by itself. And if we split it into 2 equal parts, we will get 12 and 12. And we know that if we have 2, we will always have 4. And we're checking for 8. It's 6 times 4. We're counting by 6. 6, 12, 18, 24. 4 times. And there is another number missing. And we have to check. 1, 2. Yay! 3 is missing. 3 times 8. That's perfect. 1 we checked twice. Number 2 we checked. 3 we checked and we doubled. 2 we didn't check. 4. Now here we go. We got 4 here and we doubled 3 and we got 6 here. They are sitting over here. 2 became 4 and 3 became 6. We are doubling, right? Because we know that 12 can be easily split even further. Every number, any number bigger than 12 can be divided by 2, 3, 4, and 6. And of course, it can be divided by itself. The easiest trick to solve this question is to count the numbers. How many numbers is being provided? And that will be the number of pairs being asked. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And just for the future, remember 72 has 12 different pairs. 12 different factor pairs. And finally, we've got not a composite number, but a prime number. What is a prime number? It can be divided only by itself, equally. Of course, it can be divided by 3, 4, 5, but we'll get a decimal point. We'll get a decimal number. And of course, the only factor that is really important to check first is factor 1. Then we are checking factor 2. Then we're checking factor 3 by making or by creating an imaginary plus and checking if 10 can be divided by 3. No, we disregard 3. It cannot be divided by 3 equally. And then since it can be divided by 2 and it's more than 12, it can be divided by next factor in line, which is 4. Right, we are counting by 4s 7 times. Are we counting by 7s 4 times? 7, 14, 21, 28. Right, let's move on. Well done.